Hi everyone, thanks for joining me for the second part of the SRIOV for 5G core network. So, like I briefly showed this architecture, so this is what we'll be following. So, to give a brief overview of what we discussed last time. So, like I said, this is just an example. For instance, yes, you may not necessarily need SRIOV between the SMF and the UPF, for instance, right? Since most likely they will be within, it will be a east to west traffic, right? But like the traffic entering your AMF from the G node B, yeah, that's a good candidate for your SRIOV, and also from the S3, I mean from the N3 interface from the G node B to your UPF. So that is also a good consideration to use SRIV. So that in its own, it demonstrates what we call the north-south traffic. So I have all SRIV all over. It's just like I said, it's just to give you for learning purpose. So there are two VMs. So like I said, there is one VM that is for the 5G control plane, and there is another VM for the 5G user plane. Now, I've also created a node label, so you can see there is a node label here saying all these network functions here, they are going to be using this node label as part of their node selector. So this will be using function control plane, and this one will be using function user plane. So I've decided to just include the UE run sim, UE, and the GNodeB also to run on the user plane, right? And then the IP address design shows this. So you can see here the GNodeB. I'm trying to I'm using an N1 interface in between. Of course, the N1 goes from the UE directly to the AMF, right? But then it still needs to pass through the GNodeB. So that's why I'm naming it an N1 interface there. So you see the GNodeB has the .1.1, and then the UE for the N1 interface has the 1.2. Then it goes all the way down like the AMF N2. I'm just trying to use the uh, the 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 numbering of the N interfaces to match the subnets to make it easier to follow through. So this will definitely change based on your own implementation. So ideally, if you're able to get a grasp of what you have here, then you should be able to understand how it's even done at in a large deployment. And those of you that are already familiar with OpenStack, like especially on on-prem and stuff like that, you will have all these things will be much, you'll be more familiar with it. But even though if you are not familiar with those things, if you get a capable server or a workstation, if you have the right NICs, you could deploy and use this just to test run it. So now you see the N2 interface between the AMF and the GNodeB, they're in the same subnet. Also the N4 between the SMF and the UPF, they're in the same subnet. The N3 also between the GNodeB and the UPF. And then the N6 here, you can see here that I'm also using SRIOV. So we have a test pod here. So the test pod is having 6.2 as the IP, and then this N6 interface is having 6.1. So before we go on, let's just go through the Helm chart, because the Helm chart is where I'll still be making use of this network attachment definition, which I did not include in the Helm chart for now. So I think maybe this will be the last video I'll be doing this without using it in the Helm chart. Subsequent videos now, I'll be using this directly in the Helm chart. So like I said, I'm putting this out there separately as a manifest to just show it at a glance, because it's easier for you to read instead of reading from the Helm chart. So now one quick thing I want to take note is that on the UPF, if you see the UPF here, you will see. Okay, let's first of all go through the Multus configuration. So like I said, we are injecting the Multus, right? But we are using Multus and SRIOV device plugin. if you recollect from from the first video. So we are using Multus. This is the Multus part, but then we are using a single network attachment definition for all the three interfaces. So we have the N3, N4, and N6. Why are we using the same Multus network interface? I've already explained it to us that because you have this annotation, this network attachment definition is able to pull virtual functions, network, the VF NICs, through the SRIOV device plugin from the pool. And take note, the control plane has 8 VFs and the user plane too has 8 VFs. So the Multus here is actually making use of 3 VFs from the user plane virtual machine. So we are replicating this since we need 3 interfaces, so you need to create 3 entries for this. And take note also, that's another thing you could do in Multus, is that you can actually give it a name instead of the net1 interface or net2 and all the likes. You can actually override that. So to make it easier, when you log in into your, for instance, into your pod, I've named this to be N3. So when you do an exec into the pod, you actually see this. And then also we are picking the IP addresses, which I've showed you. So the N3 we have is IP, N4 we have is IP, and N6. Now, if you do this, this is just the Multus part. But since we need 3 VFs and we are using the same network attachment definition, or whichever, whether you are using a different network attachment definition, but because we are using one here, we need 3 virtual NICs. In the resources section, you have to actually make it to be 3. So here you see in the M chart, I'm actually saying, okay, what is the SRIOV resource name? Okay, which is the same thing that we set and in the annotation for the Multus. So we are saying we need 3. So these 3 interfaces for N3, N4, and N6. But if you look at the AMF, for instance, the AMF, we only need the N2 interface. So you see here that we are only creating one instance of that, and then we are naming it N2. So if you go down to the resources section, you see that we are only using one. The same thing with the SMF. You see the SMF also is having one interface, which is the N4. So all the SBI, for the SBI, we are making use of the Kubernetes primary interface. For the GNodeB, the GNodeB also will require 3 interfaces, right? If you remember the N1 interface, the N2, and the N3. So that means that in the resources section, it has to be 3 also. So that's a brief overview. And then if we go into the values.yml for the M chart, so you see here that we are creating like the Multus, the name of the network attachment definition, because we are creating this outside of the M chart. So that's why we are creating this entry. And then also the SRIOV device plugin. This is the name of the resource that we created for the virtual NICs. Then the remaining values remains like your AMF, your network configuration, then the Multus, right? AMF has the N2 interface, and then you have it all. The GNodeB2 has its own N1, N2, N3. SMF has just one. UPF has 3 interfaces. And then also, if you remember, I said we are making use of a node selector, right? So for all the control plane nodes, we are making use of a different worker node, and then for the 5G control plane, and another worker node for the user plane. So it's a good practice sometimes, because, for instance, in subsequent videos, if I might do some videos to like maybe use DPDK or stuff like that, just to show you why you need a separate user plane function. For instance, your user plane VM might require much more CPUs or a different kind of VM, because you need a high throughput. So that's why sometimes you have to use a dedicated worker node just for the control plane, for the user plane node. So to see how we are doing the node selection, you can see also, for instance, from the UPF, you can see here that we are adding an if conditional statement here that, okay, if this value is set in the values.yaml file, then make use of the node selector. So since this is set in the values.yaml file, then this UPF will definitely be deployed to the worker. But let me quickly run the first of all, let's see that we don't have any. I'm going to use the default namespace. The reason why I want us to do this is just because to save time, because it takes some time before the worker node, before the CNFs actually come up. So these are normal commands. So we are installing the name and then the chart. So if we do a watch, or let's make use of another tool, the K9S. So the K9S is a good tool. As far as I'm concerned, it if you are learning Kubernetes from the scratch or something, it's better for you not to move into this kind of tools, right? Because you may, in some cases, in some environments, you may not have access to use this kind of additional tools. So what do? You have to fall back to your kubectl commands. So once you have mastered your kubectl commands, then it's good to have this kind of other tools. These tools make it easier for you. For instance, if you want to check the logs, if you want to exec into the pods, you don't need to be doing kubectl exec, exit, and all the likes. From here, you can see the shortcut. You can see S for shell, you can see D for describe, you can see L for logs. It makes it much easier. But then you can see that the functions are coming up. So you see the UPF is already running. Take note when you are running Multus, right? You don't get to see the IPs here from the Kubernetes perspective, because Kubernetes does not actually know about those IPs, because they are secondary. IP is not directly implemented in the upstream Kubernetes, right? So that's one thing that some people get to be confused. So when you see the IP, this is the Kubernetes primary interface IPs. And for this cluster, I'm making use of Calico if you're interested in that. So the pods are coming up. You can see there are a lot of, some are init. Init means they are waiting for some containers for some pods to be running. For instance, the first pod that needs to be run is NRF. And then if you see the Gnode B is still in init because it's waiting for the AMF. Once the AMF is in running state, the Gnode B will kick off. And once the Gnode B kicks off, then you will see the UE also will kick off. So you see here that right now the Gnode B is running. In some time, you see the UE also coming up. So we'll wait for all the pods to be in a running state, and then we'll quickly do some checks to make sure that we have connectivity across board. So all the pods are in running state now. And let's see, for instance, in the SMF, if we do type S, we're into the SMF port, and if we do an IP address, so here we see, for instance, like I said, you will see the N2 interface, and this is the IP. So we can ping the N2 IP address of the URANs in Gnode B, which will be 2.2. So 2.2, we see that we have connectivity. So let's press escape, or we'll do exit. So we can also from the Gnode B, because the Gnode B also has three interfaces. So let's see what's what's in the Gnode B, for instance. So we can let's do the IP address again. So you see we have N1, N2, N3. So for the N2, the other IP would be for the AMF. So we have done that from the AMF. Now the N1 is 1.1. So the IP for the UE would be 192.168.1.2. So we see we have connectivity. Now to test connectivity to the entry interface of the UPF. So for the Gnode B is 3.2, while the one for the UPF is 3.1. So now we see that we have connectivity. So let's see the UE logs. Okay, if we press L, let's see if we're able to see if the PDU session was successful. And yes, you can see that the PDU session was actually successful. So here you see that the UE was able to come up and was able to attach to the network. So it's a lot of steps, but then if you have all the configurations right, then everything should be seamless. So if we log in into the UE, and if we do a IP address, so we can see that we have the IP. I forgot to name this N1, but it's actually the N1 interface, which is 1.2. But the 5G tunnel for the UE is this. So if we do a ping, and then we sort it from here, and then we ping maybe the internet, for instance, we see that we have connectivity. But now take note of our diagram here. So the N6 here is making use of 192.168.6.2. So this, which is the test node here, the external node there. So if we go back into the KNIS console, we'll see this is the node here. I mean, this is the port. So this port is 192.168.6.2. And for you to do the ping, yes, you can do the ping, and then it will also be, it will, by default, what I want to say is by default, in your Open5GS configuration, let's go to the configuration, it should be easier that way. So now, normally you do your NATing or your masquerading, right? But then I've added the test, I mean, the external network test, external network, right? So that I don't want to NAT this traffic on the node. I just want it to go directly to the through the N6 and to the test port. So that's the only difference I'm doing in this demo. So any traffic that is going to 6.0 will not be NATed. And how do we know that it will not be NATed? If we do a TCP dump on the test node and we do a ping from the UE to the 6.2 IP, you actually see that we'll be seeing the direct IP from the UE. And if you are also doing this, you will need a return traffic from the external node back to the UPF. All right. So that is why I have it here that I'm routing the UE IP pool via what? Via the N6 interface of the UPF. So if we go back to let's open another, if we're able to open another tab. Let me see now. Okay, let's make use of this so that we have let me log in into the node where we have the Kubernetes config. So let me do a KNIS here also. So here, from here, let's go into the UE, right? And then let's go into the test node here. So if we do a let's see the IP address. Yeah, so we have the N6 interface there. So if we do a TCP dump, and then we specify the N6 interface. Now, if we do a ping to this IP from via the UE tunnel interface. So let's just do a 3 ping. So we see that the ping is also successful. But then the interesting part here is that the source, let me stop this, the source IP, you can see there that it's actually showing us that it is the UEIP pool and not the interface of the UPF. So the UE is actually communicating directly to the test node without NAT, and that's why you can see the UE IP here and not the UPF IP. So another way to let's do this. If we put host here, just to keep it clean. All right. So yeah, if I do the ping again, you see that. So yeah, so it's clear. So you see that we only have the UE IP to the test node. Now, if I do a ping to the internet, you actually see that it's not going to show up here because we are not using the test node for the internet access. I'm actually using the UPF internet access. So if I ping 4.2.2 the way I did again, the traffic will not show up on the test external test port because it will go through another interface. But of course, normally even your internet traffic should go through N6 and through that. But for now, it makes it a bit easier and not too complicated, right? So, but this is just to show you how if you want to like have a pure test node and then you want the traffic to go directly to the test node without doing the NAT. So essentially that's how this how you can do it with SRIOV. Take note, we have used SRIOV all through. So in some subsequent video, maybe in the third series, I'll decide if I need to maybe like do this. We can have a mix of, for instance, we can make use of the SRIOV still in this part, and then we could make use of Mac VLAN, and then maybe use one of the interfaces, maybe use the bridge interface of Proxmox just to limit the traffic within this system instead of going all the way down back to the SRIOV and all the way back up. And also, it's just to also be a good learning experience to see how you can combine, like for instance, your SRIOV and then a Mac VLAN. So with that, we have come to the end of this video. I hope it has been informative for you, and do subscribe and like and share also so that others too can benefit from it. So thanks, and see you in the next video.